on to the autoionization of water. So I'm going to break down this word, right? Auto meaning self, ionization. So it's going to turn into ions of water. Okay. So water can do what's called self ionization or autoionization. So if I have two water molecules together, some of them are going to act like acids and bases, because remember they're amphoteric. That means they can act as an acid or a base. And then I end up with an hydroxide and an H3O plus, right? This is OH minus, and this is H3O plus. So this actually just happens in water by itself. Now, not much, very, very few of the molecules actually do this, but it is constantly occurring. That's something, if you have a pure sample of water, that is happening. Okay, so for this equation, if I were to write the equilibrium constant K for this equation, I would do products over reactants, right? So the products would be concentration of OH minus times the concentration of H3O plus. Now notice I didn't put water, the two water molecules on the bottom, and that's because water, you can't have aqueous water. It's just water. It's a liquid, and remember, liquids don't actually affect equilibrium constants. So what I have written here is the K, we call it KW because it's for water. Remember, anytime you have a subscript, it just means a different type of K, but you always make them the same way, products over reactants. So at 25 degrees Celsius, KW is actually 1 times 10 to the negative 14th. Okay, this is a really small number. That means it doesn't really favor the forward direction much. So not much of it actually ionizes, but some of it does. Okay, so what we can use this for is to actually calculate the concentration of H3O plus, right, acid, or OH minus, base, in a solution. So we're going to use the K value of water to find how acidic or how basic some type of concentration is. Okay, so I am going to make a little note here about the hydronium ion and the H plus ion. We kind of use these interchangeably. We assume them to be the same thing. Okay, so what I mean by that is sometimes we might just write H plus instead of H3O plus. Yes, H plus doesn't exist by itself in water. It's always going to attach to a water molecule. So it's really H3O plus, but sometimes for simplicity reasons, we just write H plus, right? Hydrochloric acid gives off H plus. That's kind of what we're thinking. But in all honesty, that H plus attaches to a water and you get hydronium. So we kind of talk about them as the same thing. So when we start talking about pH and things, I'm really talking about H3O plus when I say H plus. Okay, so how does this play into the pH scale? Well, I'm going to show you how this whole 0 to 14 thing, you might have recognized that 14, works. Okay, so this is a log-based 10 scale. So when you're using your calculator, this is not a natural log. You have to find the LOG button. Okay, if you have a 98, it's in the catalog. So yes, you do have to get it from the catalog each time, but that's where your log-based 10 button is. Okay, so anytime we see this lowercase p in front of something, so pH, POH, yes, that is a thing. That means the negative log of, log-based 10, negative log of something. pH is the negative log of the H plus concentration. So POH would be the negative log of the OH minus concentration. And now when you add these together, you get 14 because the negative log of this plus the negative log of this equals 14. Because when you're taking log base 10, if you did the negative log of 1 times 10 to the negative 14, what would you get? 14. So this is kind of how that whole 0 to 14 scale works. It's based on these H plus and OH minus concentrations. Okay, so you are going to be using negative logs. This is just a pH scale over here for your reference. Extremely basic would mean it is a 1 molar concentration. You would be doing negative log of 1, and then negative log of 1 times 10 to the negative 14, and then you would get 14, and then something super acidic, is going to give you a pH of 0, essentially. So I do want to make a quick note about significant figures with logarithms. If this is my concentration, say this was my concentration of H plus, and I took the negative log of it, Essentially a pH then is a logarithm. And this number in front really just tells you the scale that it is. So it's on a scale of like hundredths. So that is not considered a significant figure. So only the decimals are significant figures if it is a pH. The decimals are sig figs. So if the concentration had two significant figures and I wanted two significant figures in my pH, I should actually have two decimal places. Now, don't stress too much about that. I will give plus or minus one significant figure, but that is kind of a new rule for you. So what makes something acidic versus basic? And that whole is 0 to 7 and 7 to 14. Well, it has to do with the concentration of H plus and the concentration of OH minus. Sorry, so if something is acidic, that really means I have more of the acid part, more H3O plus, than I have of the base part, OH minus. If something is basic, that would just mean I have more of the base part. So H3O plus concentration is less than the hydroxide concentration. And if they were equal, that would put me at a pH of 7. Okay, so we can calculate all of these using the equations that I gave you right up here. All right, so I am going to show you how to do these. To fill in these tables, you will absolutely have a table like this in the future on your homework and potentially on your exam. Okay, so anytime you have a concentration, to get to the pH or the POH, you take the negative log, okay? So if I give you the H3O plus concentration, which is really the same as the H plus concentration, right? I can take the negative log of that to get this, right? So negative log. Okay, so if I take the negative log of 2.7 times 10 to the negative third, I'm going to get, check what I got, 2.57. Okay, now the rest of my calculations are actually going to be really easy because I know that pH plus POH is 14. I can do 14 minus. So if I'm going between these at all, I'm going to use that pH plus POH equals 14. So my POH here must be 11.43. Now the problem, the thing that we forget sometimes is when going backwards, what is the inverse of a log base 10? Well, the inverse of a log base 10 is 10 to that power. So if I'm going from over here, so the right side, to the left side, okay, so to a concentration, I'm going to do 10 to the negative, sorry, I don't know why I made that like a triangle. That should just be a caret. 10 to the power of negative, whatever your pH or your POH is. They have to match up. POH obviously goes with OH minus, pH goes with H3O plus. All right. So if you're going to the right to get the P's, you do negative log. And if you're trying to find the concentrations from the P's, you do 10 to the negative. Okay, to figure that out. So in order to get my OH minus concentration for this first row, I would do 10 to the negative 11.43. Now, do not leave that number in that box. That's not a real number. You should not have a decimal in the exponent. So please type this into your calculator and push equals, okay? 10 to the negative 11.43. If you do that in your calculator, you get an actual number, 3.7 times 10 to the negative 12 molar should be your answer. Okay, so do not report 10 to the negative 11.43. Report 3.7 times 10 to the negative 12. Okay, so the last thing I'm going to ask you is the solution acidic or basic? The easiest way to determine is just look at your pH, right? We know pH lower, pH higher, what that means. A low pH, anything lower than 7, of course, means it is acidic. All right, so why don't you pause here, try the second row, and then check your answers. All right, and here you go. I first did 14 minus 4.28 to get my pH. And then to get my H3O plus, I did 10 to the negative 9.72. To get my OH minus, I did 10 to the negative 4.28. And then I look at my pH, this should be basic. So if you have questions on that, please let me know.